Welcome back to Fabian Electrical Services Inc. Today we're starting episode 1 of the grounding and bonding series, and we're breaking down the most important part of any electrical service, the main bonding point. If you understand the main bonding point, grounding and bonding finally makes sense. If you get it wrong, you create short hazards, parallel path, and code violations. Today I'm going to show you exactly where it goes, why it exists, and how the OESC 2024 wants it done. What is the main bonding point? Let's start simple. The main bonding point, also called the MBP or the MBJ, is where the neutral is bonded to the metal enclosure of the service. This is the only place where neutral and ground connects together. Everywhere else in the system, subpanels, disconnects, downstreams, AC panel, pool panels, the neutral must stay isolated. Without a correct main bonding point, faults won't clear, breakers trip slowly, stray voltage appears on metal, short risks increase, code violation piles up. This one point controls the whole grounding and bonding system. Under OESC 2024, the main bonding point must be located at the first means of disconnect, not the meter, not the subpanel, the first switch or breaker that can shut off all power to the building. In homes, it's the main panel. In some industrial commercial setups, it's the disconnect before the panel. Inside that point, you will see one of these: a bonding screw green, a bonding strap, a factory installed jumper. This device ties the neutral bus to the metal enclosure, creating the low impedance path needed for faults to return instantly. So in this situation, my main bonding point will be at my main disconnect that is located at the side of the home where it was bonded from that point on. The bonding screw is one of the most misunderstood pieces of hardware in the trade. Here's how it works. You have a neutral bar floating inside the panel. The bonding screw threads into the enclosure and touches the neutral bar, connecting metal to neutral. This creates a return path for fault current, a low resistance path to trip breakers, one single grounding reference point. If you miss the bonding screw in a service panel, you get stray voltage, tingles on appliances, breakers not tripping fast, metal boxes reading hot under faults. Now let's talk about grounding. The grounding electrode conductor, the GEC, connects your service to the earth. But here's the most important rule. The GEC must land at the main bonding point, not in a sub-panel, not on a random ground bar. This means your ground plate wire or ground rod lands on the neutral bar in the service or the grounding lug inside the disconnect. This becomes your zero reference, stabilizing voltage and maintaining surge, lightning, and faults. Once you leave the main bonding point, everything changes. Downstream panels must have isolated neutral bars, have bonded ground bars, have 4-wire feeders, hot/neutral/ground, have no bonding screw in the neutral bar. If you bond neutral and ground downstream, you create parallel path. You energize metal parts. You backfeed current on conduit. You violate code. You risk shot every time someone touches metal. This is the number one mistake apprentices make. Only one bonding point at the service. If you ever see two bonding screws, neutral and ground, tied together in a sub-panel, neutral bar touching the case, GEC landed in the sub-panel, that's wrong, that's dangerous. Proper grounding and bonding is what keeps the entire system safe and predictable. And when it's right, it makes troubleshooting a million times easier. This is episode 1 of our grounding and bonding series. Next episode, we're covering grounding electrode conductors, size, location, and OESC rules. If this helped you, hit subscribe, drop a comment, and stay grounded safely.